Alrighty, hopefully you've got the solving the three linear equations under control. Now we're just going to put them into applications. So basically, when we have a unique solution, right, that's what we're looking at here, when they all meet at one spot. When we have got the situation where we have the infinitely many, so that's when we have the 0, 0, 0, all right, on the bottom line there. That's when we express, the parametric x or let z equal t, and then we find an expression for y and x in terms of t, right? That gives us the equation of the line where they're meeting all in one line, okay? That also can be the case when we have just two equations with three unknowns. So we've got two planes, they can meet at a common line. That was the first part of the question that I sort of asked you to skip. And then, of course, we're looking at when we have no solution, okay, then we're looking at when they are parallel. We could have two lines, two planes that are coincident on each other, and then the other one is parallel, so again, they don't meet. And we can also have the two planes here where we've got them parallel. So these are the ones that we're going to find solutions for. So the unique, and when they meet at a common line, like so. So onward to question 4. Okay, that's a situation. Now, I've just done the solutions already, otherwise the video is going to be incredibly long. So hopefully we're under control with how to find our augmented matrix. It's just the coefficients we put in there. Our first equation already had a coefficient of 1, so I didn't change the order. I kept it as it is. You're quite capable of reading how we go. Make sure that you are putting your row operations there. You've got to have those. I also want to see the working out that you've got. Now, I was a little bit naughty and I didn't do it for this first one because, quite frankly, I'm just taking row 2 away from row 1. They're already there, so I went straight in. But any of the others that you have to do a little bit of multiplying and then subtracting, please, please, please put your working out, right? Essential. The examiners want to see that. And then when you get down, again, read through that you are quite happy. I'd like to think that you aren't watching this video, you're doing it yourself and you're just watching the last bit if you've got any issues. So down here, we've got that's minus 11z equals minus 44. Get rid of the times 11 divide, that's all groovy. Then we pop it back into our second equation here because that's 2y. Take 3 times z, but our z is the 4, equals minus 16. So we've got 2y. Take 12 equals minus 16, and therefore 2y equals minus 4, y equals minus 2. And then we just pop both of these solutions back into our original. And we've got x equals minus 5, and it's going to, we're going to add y, so add minus 2, and then we want to take z, so we end up with x equals minus 11. I just realized I stuffed that, right? So it is minus 5 plus z, and our z is the 4, and then it's take y, which will be plus 2. That's what happens when you go a bit quick. So we end up with x is 1. That's better. Okay, so always double check, and you can again check this on your calculator. So into equations, simultaneous solutions, 3 unknowns, and away you go. So this is the situation where we are going to have a unique point of intersection. So we're looking at this situation here. Let's now go on and do part B. Okay, so we've got B. We're going through, written it all in, made sure that we don't lose a minus as we're going. We want to make a 0 appear here, so we're going to say 2 lots of row 1 minus row 2. Okay, again, please make sure that you show your little steps. So it's 2 minus 2, I'm timesing row 1 by 2, 4 and 2, and then we're going to subtract. Might find this irritating, but please, 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 it's essential. 2 take 2 is 0. We get minus 3, 5, and minus 6. Pop that in there. And then to get a 0 in this position, we have to times row 1 by 5. Okay, again, we're always going back to row 1. So we're going to say 5 row 1 minus row 3. Do it to the side and pop your answer in. Just to save a bit of time when we prepared earlier. So that's your 5 row 1. We're subtracting 5 take 5 is 0 and so on. So what we end up here is 0 minus 3, 5 minus 6, and you can see that these are exactly the same. So my next step for when I want to make this become 0, what's going to happen is, remember these are still going to be the same. What's going to happen is we will say the new row 3 will be row 2, take row 3, and 0 take 0 is 0, minus 3 take minus 3 becomes 0, 5 take 5 is 0, and lo and behold, that's a 0 as well. So this is a situation where we now have infinitely many solutions. Okay, and we have to say, right, we will let z equal t. That's the best bit. Now we have to find y. So we're looking at our second equation here. So it's negative 3y. Now, because these are starting to get a little bit crazier and we're working quickly, I like to actually write my whole equation here and then sub it in. Now, as I'm doing this, I want my y to be positive, so I'm going to say that's going to be 5t, the 6 is coming over, which makes it plus 6, equals 3y, and therefore y becomes 5t plus 6 all over 3. We're nearly there. We now need to find x. Not so pleasant, but we can do it. Okay, because we love fractions. So we've got x minus y plus 2z equals 1. So here we go. X will be, I guess you could have done that at the beginning, gone, well, that will be 1 plus y take 2z. So it's 1 plus 5t plus 6 over 3 take 2t. Okay, and to just make this simple, it's your basic fractions. Let's just put it all over 3. So 1 times 3 will be, that's 3 plus 5t plus 6, and we're going to times this by 3 as well. So that becomes minus 6t, and that means it's all over 3. And now I can just gather my like terms. So 3 plus 9, we'll put the t's first. Actually, that'll be minus t plus 9 all over 3. So my solutions now, my infinitely many solutions, which happens to form the equation of a line, okay, is we've got z equals t, y equals, and then x equals this, and you should write them all out nice and neatly there, and that's your equation of a line. So we're looking at which situation here? We're looking at this one here. Okay, how do we know that it is not going to be this one, right? So we're looking at, that would be that. We've got 3 planes and they meet in a common line. How do we know that it's not that one? Right? It's not that, and it's not this, right? Because we haven't got 2 coincident planes going along there. And how do we know that? Because it's not a multiple. One equation isn't a multiple of the other. Okay, so we haven't got, you know, this isn't 2 minus 2y plus 4z equals 2. It's not a multiple. If you sort of want to know what it's going to look like, oh well, I bet one's going to be coming up shortly. So let's now go and have a look at C. Okay, so it's C, felt like a change of color. Once again, we want to get a 0 here and a 0 here. So we're going to, for our row 2, this should be old hat for you by now, we're going to go 2 row 1 minus row 2, and for our row 3, it's going to be, you guessed it, 3 row 1 minus row 3. So you go ahead and you do that, and by the magic of technology, I'll just pop the answers in a moment. Okay, bang, here comes our solutions. Okay, you can see my working out to the side over here. That's why it's good, because you can see you might make some silly errors along. All right, we now want to make sure that we get a 0 here. Okay, so we have to rewrite all of this. Some of you will find this very satisfying. I find it quite soothing. 0, 5 minus 1, 11. Okay, so to make this become a 0 here, we are going to have to say that's going to be 2, row 3. Oops, 2, row 2. There you go, not paying attention. 2, row 2. Take row 3. So we're looking at 0, 10, minus 2, 22, 0, 10, minus 2, 22, and look at that. They're all the same. So once again, we end up with the situation where we've got infinitely many solutions. So try this one again. We're going to go let z equal t. Therefore, we've got 5y, right, from this line here, 5y equals 11 plus z. So that means we've got 5y equals 11 plus t. I'll just lower our page. So therefore y is 11 plus t over 5. I'm going to now plug that back in to get x. So x on the top line equals 8. Take 2y plus z. Right, I've just got pop those on the other side. So x will be 8 minus 2 lots of 11 plus t over 5 plus t. We do our trick where we're going to put all of them over 5, which means we have to multiply through by 5, so we get 40. I'm going to expand my brackets, minus 22, take 2t, plus we have to times that by 5, okay, because it's all over 5. So double check, 40 divided by 5 is 8, 5t divided by 5 gives you the t. And now you can just simplify. So we've got x equals, oh, what's 40 take 12? We've got 18 plus 3t all over 5. Now I'd like you to look at the solutions for this one in the textbook, because they've done it slightly differently and they have let y equal t. And you're allowed to do that, right? It's just going to give you a slightly different version there. So if you let y be t, what happens when you now find z, right? If you put z on the other side, because I'll have 5y take 11 equals z, you will see that your answer for z hasn't got the fractions in it. You're avoiding the fractions. So we end up with 5t take 11 equals z. And then you can pop that in and find your value for x. So it's quite nice. It's when you've got a single, right, a coefficient of 1 or minus 1 there for z, then you let y be t. However, that's not always going to happen, so we just did this to just give you practice to make sure you know how you can find your nice value for x. So keep an eye out for when that coefficient is 1, and then you can let the other one, you can let y be t instead of z. Okay, now onward to d. Might just go ahead going all the way through. Hopefully you are noticing something about these two equations as you are writing them down. So if I times this by 2, 2 minus 1 times 2 is minus 2, 1 times 2 is 2, 2 times is not that. So hopefully what we're looking at already is we're going, we've got these parallel planes going on, okay? And when we do our row operations, boom, 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 we get this, and it's at this point here where we're going to have alarm bells, because this is going to end up being, we've got 0z equals 5, and that's not possible, okay? So this is when we would be saying no solution, okay? They're inconsistent, doesn't work. Okay, so we've got our parallel planes, and we've got one that would be cutting it there. So if we go back to our original pictures, okay, we're going to be looking at like this one. We've got the two parallel and they're intersecting possibly in 2 spots, and we don't do that. We're going, nope, we can only find where we've got a unique solution when they meet at one common line, and that's it. Oh, it could be that one. No, it's not that one, because they're not coincident, okay? coincident, they would have to be a multiple of each other. Okay, and that would have to be that this last one here, when we talk about D, if we get to it, okay, they would be coincident if that was then 16. And then we can give a solution. But for this one, we're not going to, because that's not. Let's have a look at E. Maybe that will be similar to the other one. Right, let's have a look at E. And lo and behold, hopefully you notice, let's have a look at this and this one. If I times this by 3, what do I get? Wow! So hopefully we can predict what is going to be coming our way, because it looks like those are coincident lines. So we get 3. Oops, what was I doing? So what we want to try and do, I've already written this, we want to make a 0 here. So we're going to say our new row 2 is going to be row 1 minus row 2. 1 take 1 is 0, 1 take. We get 2 minus 2 take 1 is minus 3. We get minus 3. And for our row 3, when I say 3, row 1, take row 3, I get 0, 0, 0, and a 0. So this, in effect, is what we're saying is that we've got our two coincident planes here. We've got one on top of the other, and we're going to have another one that's cutting it. And so then we can have, oops, that was meant to change color. Then we can have our line, our common line of intersection there. So this is where we will say let, right? And again, we don't have to worry about which one should we let be t, because we haven't got a coefficient of 1 anywhere there. So we'll just stick with let z equal t. So to get our y, it's, okay, get our y. Now we're just popping it in to get our z value here. So make everything have 2. So we end up with 2 plus 4t minus 3t plus 3 all over 2. So we've got t plus 5 over 2 as our x. Now once again, this is we've got our common line here. So because we've got our coincident planes here, right, which model does that look like? Right, that's this one. We've got our two coincident, and we've got the line that's intersecting, and that's the equation of the line that you just found. Okay. Now we started at question 4, and I did that for a reason, because what happens when the question we just did then, when we had one row disappear altogether, okay, that was basically the situation that you have here when you're only given 2 rows of equations. So you do the same thing, you'll do the elimination row 1, take row 2, or 3 row 1, take row, and you have to then give your let z be this and let y be and so on. But you know, keep going on with question 5 and 6, and we'll come back and do those ones together in class.